All right, so we should be pretty adept at identifying the different forces and types of solids at this point. Next, we're going to be looking at how to define the percent mass of composition. Why would we care about that? Well, the reality is, like we've talked about, we can't measure these molecular compositions directly. However, these molecular compositions determine all of the properties of a substance. So something like strychnine poison has a very specific chemical structure. But if, let's say, a forensic chemist, whatever that person's name is, had to figure out, was someone poisoned, they'd be able to determine the percent of certain substances in that person's blood. But they wouldn't be able to just straight out identify the chemical composition. So they would need to be able to do a percent composition by mass. So that's what we're going to be looking at next. We're going to look at how to do that. So the general form of this is you take the element you're looking at, so element, divided, so the element, the mass of that element, divided by mass composition, and then just times 100%, which we should all know how to do that part by now. Okay? We're going to look at 3 examples. We're going to look at methane, SiO2, and lithium fluoride. Let me just erase that little guy, and then we'll get started. So our first step is we need to know the mass of each individual element and the mass of the whole thing. And we're looking at molar mass. Since we're only looking at the percentage, we don't need to know the actual grams. Molar mass will do just fine. So CH4, that's methane, that's going to be carbon, hydrogen, and then the molar mass of the whole thing together. Carbon, it should be almost instinctive, whatever, at this point. 12 grams per mole. Hydrogen is 1 gram per mole. CH4, there's 4 hydrogens, 1 carbon. We've already done this. We should already be able to figure this out. It should be 16 grams per mole. So what is the percent composition? Well, what I'm going to do for carbon is I'm going to say, well, there's 1 carbon. So 1 carbon times the 12 grams per mole divided by 16 grams per mole of the whole thing. I'm just going to multiply that by 100% on my own. So break out my calculator. I'm going to take 12 divided by 16. That's 75%. So 75% of methane's mass comes from carbon. So if I was trying to analyze a substance and figure out what it is, and I find that, oh, I know I've got carbon and I know I've got hydrogen, what's the ratio that I have in that? Well, I'm going to have 75% of this is carbon. Wonder what that could be? Let's look at the percentage of hydrogen. So for hydrogen, I've got 4 of them times 1 gram per mole divided by that 16. What's that going to work out to be? We should all know this. Punch in the calculator. 4 divided by 16 should be 0.25. That's going to give me 25%. So if I was investigating how many grams of each thing there is, let's say I had 100 grams, well, 75 grams would be carbon, 25 grams would be hydrogen. I can work the math backwards and I'd be able to determine, well, that must be methane. Simple enough. SiO2, let's do the same thing. So I've got silicon, I've got oxygen. So silicon, you can look this up. I already did before the video to waste as little of your time as possible. Silicon has a molar mass of 28.1 grams per mole. Oxygen has 16 grams per mole. And together, SiO2 is 60.1 grams per mole. Okay. Then looking at the percent composition, I'm going to take silicon. There is 1 silicon in each copy of this. So 1 times and the molar mass, 28.1 divided by 60.1, the total molar mass. So just punch that into the calculator, 28.1 divided by 60.1. That gives me 0.4675, so we're going to round that to 46.8%. So 46.8% of this molecule is made up of silicon. Then let's do the same thing for oxygen. That's going to be 2 times 16. It's 2 because there's 2 oxygens here, so 2 times 16 divided by, and then that total molar mass again, 60.1. Then let's punch that in. 2 times 16 divided by 61. That gives me 53.2. Now that should make sense because these two together makes 100%. Should work out to be that value, okay? Now lithium fluoride. Yep, plenty of room. Yeah. I can see myself in the camera. It's kind of fun to look at myself. I feel a little vain, but I'm okay with it. All right, lithium is 6.9 grams per mole. Fluorine, 19 grams per mole. So lithium fluoride together is 25.9 grams per mole. Now it's a 1-to-1 ratio, so to find out the percent composition of lithium, I'm going to take there's 1 lithium times 6.9 divided by 25.9. That will give me, okay, 6.9 divided by 25. It's going to give me 26.6%. So then, if I do the math right, this should come out to 73.4%. Right? Yeah. So then this one, is right. Whatever. There we go. Okay. This is 19 grams times 1 fluorine divided by 25.9 equals 19 divided by 25.9 is 73.3. Actually rounded, 73.4. Right on the money. Okay, there we go. That's how to determine the percent composition. If you have any questions about that, ask them below. I expect that these first 2 pages of percent composition should be done by end of day tomorrow. I will post the answers to them tomorrow. Thank you very much.